Okay, I have some more expressions here that involve radicals and fractions. We want to see if we can put them in simplified form. All right, so here's our first one, the square root of 12 divided by 6. So I'm going to first put that square root 12 in simplified form by thinking of 12 as 4 times 3, all divided by 6. So again, simplified form, I'm thinking of what's the largest perfect square that divides 12, and I factor it into that perfect square times whatever's left. Then this is going to be 2 square root 3, all divided by 6. And now I'll divide out that common factor of 2 that appears in the numerator and denominator and end up with a numerator of just square root 3 and a denominator of 3. So there's the answer to that problem, and that's how this simplifies. This, if you want, is kind of a thinking step. Maybe you just think this to yourself and don't write it down. You say square root 12, well, it's the square root of 4 times 3, so that's going to be 2 square root 3 when I apply those properties of radicals. Okay, let's look at this one now. Here I'm going to have 5 times square root of 18. Okay, 18, the largest perfect square that divides that is 9. So I'm going to write that as 9 times 2, all divided by 15. So that'll be 5 times, okay, 9 square root 2, square root of 9 times 2 is going to be square root 9 times square root 2, or 3 square root 2, all divided by 15. And remember, this is multiplication right here. Those two things aren't stuck together, the 3 and the square root 2. So that's multiplication, so I can divide out my common factor 15 that I have in the numerator and denominator, and the result is just square root 2. So again, this right here, maybe you want to think of that as a thinking step. Maybe you don't write it down. You say square root 18 is square root 9 times 2, which is going to give me 3 square root 2. But here's where you reduce to lowest terms in that last step. How about 6 plus square root 8 over 2? It'd be a mistake to divide 2 into 6 right here because I can only divide out common factors, and 6 is not a factor of the numerator. So in order to do this problem, I'm going to start with the same first step. I'm going to write square root 8 in simplified form. 8 is 4 times 2, so square root 8 is going to be 2 square root 2, all divided by 2. Now I see I have a factor of 2 common to the numerator and denominator. I'll factor that out. What's left is 3 plus square root 2 in the numerator. And then I'll divide out that 2, and my answer is 3 plus square root 2. Okay, so same first step right here. I write this square root 8 as 2 square root 2. That's how I put it in simplified form by thinking to myself, 8 is 4 times 2, and the square root of 4 is 2 times that square root of 2 that's left there. Okay, then I factor in order to see what the factors of the numerator and denominator are, and then I divide out the common factors I have. So I end up with 3 square root 2 over 2. How about negative 1 plus square root 45 over 2? Let's try that. Negative 1 plus, okay, 45, let's see, how about 9 times 5? 9 times 5 is 45, so 3 square root 5, all divided by 2. And I see that the numerator can't be factored any further. I have a 2 in the denominator. That's as far as I can go. But at least I have written that radical part in simplified form. I can't reduce to lowest terms because it is in lowest terms. Okay, one last problem. 4 plus square root 36 over 2. That's going to be 4 plus the positive square root of 36 is 6, all divided by 2. Now I can actually add the numerator, add the numbers in the numerator, and get 10 divided by 2, which turns out to be 5. Okay, so that problem just turns into a little division problem, or you can think of it as reducing to lowest terms, end up with just the number 5. So a variety of problems here involving radicals and fractions and the way in which we put them in simplified form over here.